Okay, guys, for number 27, we are looking at the 6 signs of that a chemical reaction occurred. So we use the mnemonic, which is girls or guys love their cell phones on. So I'm going to put guys love their cell phones on. So for G, it's going to be gas, bubbles, smoke, anything there. Okay, for L, that's going to be light production. It produces light, so fire, any sort of glowing glow sticks. For T, that is a temperature change. And these are all unexpected. So if I put something in the refrigerator, obviously I hope that it gets cold, or on the stove, I hope that it gets hot. But if you just mix something together and now all of a sudden it gets warm or cold, then that's evidence that a chemical reaction has taken place. Color change, we saw a couple of examples of that on Friday. Precipitate. A precipitate is, I like to remember it just like, because it sounds like the word precipitation, which is rain. And precipitate kind of is the same thing. It's basically you've got a solid that forms and falls like rain falls to the bottom, Then we've got O, which is going to be odor, and that could be good or bad odor. So when you walk in and you smell cookies or you smell what's for dinner, that is because chemical reactions have taken place. But if you also smell some roadkill on the side of the road or something, that is because chemical reactions are taking place inside of that little area. Okay, 28. Label the following as a physical or chemical reaction or change. So dissolving. And guys, I'm going to put a big star by this one because dissolving is probably one of the most common ones that people think this is actually a physical change. You can dissolve the sugar in something and evaporate the water or whatever else liquid it is, and that the sugar will still be there. Maybe not in the little crystal forms, but it's still sugar. Leaves changing color in the fall. That is actually a chemical change. It's literally their little bodies, the chlorophyll inside of those, breaking down and changing colors. They're like decaying. We think it's pretty, but it's their death. Baking soda absorbs acid. Think of a paper towel absorbing. This is a physical change. Sorry. And guys, again, if it is not one of these over here, I don't see any absorbing over there or dissolving over there, then it is a physical. If it is not one of those, then it is a physical change. A white solid forms at the bottom of a beaker after mixing two clear liquids. Well, this is the precipitate. Okay, so it is considered a chemical change. Boiling water. Again, boiling is not one of these up here. So boiling water is going to be a physical change. You can capture that boiling water and it's still water vapor. Melting a candle, it's still the candle, that is physical. Still a candle, you can gather all the candle and make a new candle out of it if you put a new wick in it. Burning sugar, anytime you burn things, it turns black. And so that is a color change, which means that it is a chemical change. Water evaporating into gas. Again, this evaporating is not up here, so it is a physical change. Evaporating into gas, it's still water vapor. 29, a student combines a white powder into a clear liquid. So we've got white powder, clear liquid. They observed fizzing, so there's gas. An increase in volume, okay, that's just volume. An increase in temperature, so there's a temperature change. That's chemical. And the solution turned pink, that's color change. So which of these is not an indicator that a chemical change occurs? Volume is not part of girls love their cell phones on, so it is the volume. Of course it's going to increase because you put something into the powder into the clear liquid, and it takes up space. Number 30, in an experiment, two flasks of unknown clear liquids are combined in a beaker and the following observations were obtained. We need to circle all of the observations that indicate a new substance was formed. So the solution color remains clear. So that's, well, there's no color change, so no color change. So that's not anything. The amount of solution in the beaker increased. Well, of course, that's obvious because we combined two liquids. So that's physical, that's physical, that's physical. The solution temperature changed from 10 degrees to 20. Nowhere in here does it say that they put it on a in the oven or on a hot plate or anything. So that's a chemical, it's a temperature change, that's chemical. Some of the liquid remained in the flask. Okay, well, again, that's just because you can't get everything out of the something. So this is the only one that that indicates a new substance was formed. All right, number 31. An experiment is performed in which a crystal-like substance is added to a beaker filled with room temperature water. The following observations are made. All of the observations are evidence of a chemical change except, so we're looking for dissolving. Okay, well, that is a physical change. We said that's the one that we put the big star next to. Dissolve is a physical change. A precipitate was formed. That's chemical, because that's part of the cell phone, P. The bottom of the beaker feels warm to the touch. Okay, nowhere in here did it say that there was a oven or anything here, so that's chemical. And bubbles began to form. That's my gas, and so that's chemical. My correct answer is number 1. Number 32. In which of the following examples has a chemical reaction occurred? So we're looking for our city girl, our girls love our cell phones on. After putting liquid batter in a hot pan, the batter solidifies. That means it gets hard and begins to turn brown. So this is a color change. Color change. That could be it. After turning on a blender filled with fruits, the fruit is chopped up and mixed together. Well, the fruit is still fruit. It's just in smaller pieces. So this is a physical. After taking a tray filled with ice cubes out of the freezer, they begin to melt. Melting it's still water. It's just no longer frozen water. So that is physical. No new substance has been formed. After adding a spoonful of sugar to a mug of hot coffee, the sugar dissolves completely. Again, guys, this is the big one. Dissolves is a physical change. So this is my answer. This showed a color change, which is one of the evidences we need.
All right, now we're on to counting atoms. Number 1, remember there are 2 main steps to counting atoms. First one, write down the different elements right here. Write the different elements, then ask your 3 questions. Is there a subscript? Is there a coefficient? Are there parentheses? Some examples are here. I'm not going to walk you through them because you guys can practice on that if you want. So I'm going to skip all the way to the first one down here. NaOH. First step, we're going to write down all of the elements. We have Na, we have O, and we have H. Is there a subscript after Na? There is not. Is there a coefficient? There is not. Are there parentheses? So there's one O, Na. On O, is there a subscript? No, there is not. Is there a coefficient? Are there parentheses? And for the H, the hydrogen, is there a subscript? No. Is there a coefficient? No. Are there parentheses? No. Giving us a total of 3 atoms. Total of atoms is 3. All right, let's look at number 2. Number 2, we have hydrogen, H. We have nitrogen, N, and we have oxygen, O. Does hydrogen have a subscript? It does not. Does it have a coefficient? It does. Does it have parentheses? No. Does nitrogen have a subscript? No, it does not. Does it have a coefficient? Yes. Does it have parentheses? No. Oxygen does have a subscript right there. It does have a coefficient, and it does not have parentheses, giving us a total of 20 atoms. Total of 20 atoms in this molecule. Number 3, we've got magnesium and we've got chlorine. Magnesium, there is no subscript, no coefficient, and no parentheses. Chlorine has a subscript, no coefficient, no parentheses. for a total of 3 atoms in this molecule. And number 4, we have lithium, Li, and we have oxygen, O. Lithium has a subscript of 2, a coefficient of 4, and no parentheses. Oxygen has no subscript, a coefficient of 4, and no parentheses. Total number of atoms would be 12 total atoms. And number 5, we've got magnesium, we have chlorine, and we have oxygen. We know the L goes with the C because it's a small L. I's do not look like that. On the periodic table, capital I's would have the bars on top. Magnesium does not have a subscript, does not have a coefficient, does not have parentheses. It is a 1. Magnesium is outside the parentheses, so it does not count for the parentheses. Chlorine has no subscript, it has no coefficient, but it is inside the parentheses, and the number outside is 2, so we've got 2 chlorines. Oxygen does have a subscript, it does not have a coefficient, and it has parentheses with a 2, giving us 6 for a total of 9 total atoms. 9 total atoms. Number 6, we have lithium, we have sulfur, and we have oxygen. We have a subscript of 2, no coefficient, no parentheses. Sulfur has a no subscript, no coefficient, and no parentheses. And oxygen has, that's a 4, it has a subscript of 4, no coefficient, no parentheses, for a total of 7 total atoms. Over here we have number 7. We've got zinc, which is Zn. We have O for oxygen, and hydrogen is H. Zinc does not have a subscript. It does have a coefficient, and it is outside the parentheses for a total of 4. Oxygen does not have a subscript. It does have a coefficient. Remember, this 4 applies to everything in that molecule because there's not a plus sign or anything separating it. And then, of course, we have a parentheses for the O with a 2 on the outside, so we get a total of 8 oxygens. And hydrogen does not have a subscript. It has a coefficient, and it has parentheses. So if we add 8, 8, and 4, we get 20 total atoms in this molecule. And number 8, we have Na, which is sodium, C for calcium, H, and O. So we've got 4 total different elements in this molecule. Na has no subscript, no coefficient, no parentheses. C has a subscript of 2, no coefficient, no parentheses. H has a subscript of 3, no coefficient, no parentheses. And O has a subscript of 2, no coefficient, no parentheses. Add these up, 1 plus 2 plus 3 is 6, plus 2 more is 8 total atoms. Number 9, we'll switch colors here. Number 9, we have aluminum, Al, and oxygen, which is O. The Al has a subscript of 2, a coefficient of 3, no parentheses. The oxygen has a subscript of 3, a coefficient of 3, no parentheses, for a total of 15 atoms. Number 10, we've got N for nitrogen, H for hydrogen, and Cl for chlorine. N has no subscript, no coefficient, no parentheses. H has 4 is a subscript, no coefficient, no parentheses. Cl has 1, no coefficient, no parentheses, no subscript, no coefficient, no parentheses, for a total of 5 total atoms. Number 11, we've got Zn, S, and O. Zn has no subscript, a coefficient of 5, no parentheses. S has no subscript, 5 is a coefficient, no parentheses. And O has 4 subscript, 5 coefficient, no parentheses, and for a total of 20, giving us 30 total atoms. And last one, Zn, P, and O. Zn is 3 times 1 times 1. P is 1 times 2 times 1, 1 Okay, I ran out of time there, but there's the solution for number 12. Remember, this is due Wednesday, the 11th. Benchmark is the 11th. Good luck.